So in this video, we're going to talk about the basic derivative rules. It's very tedious to use the limit definition to evaluate derivatives, so we can use these limit rules. First rule is a constant rule. The derivative of a constant with respect to x is 0. The constant multiple rule says that if we have a constant times a function, we can pull that constant out in front of the derivative operator to get that we get c df dx. Or again, if you want to, you can use this notation, c f prime of x. The sum rule says that if we're taking the derivative of a sum of functions, we can break that up and just find the derivative of each function separately and then take the sum of those derivatives, like this. The power rule says anytime you have an x raised to a power, you can bring that power down in front and then subtract 1. So the derivative x to the n is n times x to the n minus 1. This works for almost any value of n. So let's apply these rules now to find the derivative of this function here. But for this first term, we'll pull the 3 out front and then just take the derivative of x to the 7th. So that would be 3 times 7x to the 6th. And then we're going to take this, we're going to have 5 times x to the 4th minus 1/3 times 3x squared plus 2x minus 3. And the derivative of the last term is 0 since that's a constant. We can then multiply this through, simplify this all out, get 21x to the 6th minus 20x to the 4th minus 1x squared plus 2x minus 3. And that's our answer. For this next problem, notice we have a negative exponent here while the power rule still applies. So we're going to find the derivative dy dx. That's going to be 2 times negative 3x to the negative 4, right? Negative 3 minus 1 is negative 4. Plus 4 x to the 1. The 1 comes down. 1 times x to the 0. X to the 0 is 1, so we just have a 1. And then pi, the derivative of a constant, pi is 0. We can simplify this then. This is negative 6x to the negative 4th plus 4. And that's the answer. Okay, for these functions, we'll want to rewrite it so that it's easier to take the derivative applying the power rule. So first I'm going to rewrite the function. This is going to be x to the 7/3 minus x to the 1/2 plus 2 times x to the 2/5. Now, when I take the derivative, I can apply the power rule. So this 7/3, the power, comes down in front, and then I subtract 1 from 7/3. Well, that's the same as subtracting 3/3. 7/3 minus 3/3 is 4/3. For this one, I get 1/2 x to the 1/2 minus 1, which is negative 1/2. And then for this last one, I get 2 times 2/5 times 2/5 x to the negative 3/5. 2/5 minus 1 is negative 3/5. Now I can rewrite these. Let me simplify first. 7/3 x to the 4/3 minus 1/2 x to the negative 1/2 plus 4/5 x to the negative 3/5. And now if I want to rewrite it in the form similar to what I started with, we could stop there. But if we wanted to rewrite, I could write 7/3 times the cube root of x to the 4th minus 1/2 times the square root of x minus 4/5 times the 5th root of x cubed. Okay, for this one, I'm going to rewrite this so that I have negative exponents and can easily apply the power rule. So this is going to be x to the negative 1 plus 4x to the negative 2 minus, now in this case, the 3 and the x are being squared. I'm going to go ahead and square the 3 out to get 1/9, and then this would be x to the negative 2. Now when I take the derivative of g with respect to x, applying the power rule, I get negative 1 times x to the negative 2 minus the 4 times the negative 2 becomes minus 8x to the negative 3. And then this becomes plus 2 ninths, negative 2 times negative 1 ninth, 2 ninths, x to the negative 3. I can rewrite that in a similar form that I had to begin with. So that would be negative 1 over x squared minus 8 over x cubed plus 2 over 9x cubed. Okay, and that would be my final answer there. For this one here, what I can do is I can distribute this 2x to each of these three terms separately. So that's going to be negative 16x squared divided by 2x plus 5x divided by 2x minus 1 over 2x. That's just the distributive property. Now I can simplify this. Negative 16 divided by 2 is negative 8, and x squared divided by x is x. This gives me 5 halves. The x's cancel out. And then I have minus 1 half. I'm just going to rewrite this as x to the negative 1. So again, I can apply the power rule pretty simply. The derivative then of f with respect to x is going to be negative 8 plus 0 here, and then this is going to be plus 1 half x to the negative 2. And if I wanted to, I could rewrite that as negative 8 plus 1 over 2x squared. Either way, either form is good. Okay, now let's go ahead and do this and then evaluate the derivative at a particular number. In this case, I start with this f of x. I'm going to find f prime of x to start with. Following the rules again, the power rule, the 4 comes down. 4 times 1 half is 2. X cubed, negative 2 times negative 4 is plus 8 x to the negative 3. And then the derivative of e, Euler's number, is 0. That's a constant. Okay, now I'm going to evaluate f prime of 3. 2 times 3 cubed plus 8 times 3 to the negative 3. This becomes 2 times 3 cubed is 27 plus 8 over 27. And then I can simplify this down. This gives me 1458 plus 8 over 27 gives me 1466 over 27. And these don't have any common factors. The factors of 27 are 3. 3 times 3 times 3. And 1466 is not divisible by 3. So that's the simplest I can make that fraction. Okay, for this next problem, I'm going to rewrite this as x to the negative 1 half plus 4x. So again, I can apply the power rule easily. So y prime is going to be negative 1 half x to the negative 3 halves plus 4. Now, dy dx or y prime, same thing. If I evaluate this at 4, y prime of 4, I get negative 1 half times 4 to the negative 3 halves plus 4. Negative 1 half, 4 to the negative 3 halves would be, I can take the square root of 4, which is 2. 2 cubed is 8. And then that goes into the denominator because of the negative exponent, plus 4. So now I have negative 1 over 16 plus 4, which is going to be 63 over 16. Negative 1 plus over 16 plus 64 over 16 is 63 over 16. Okay, let's go ahead and now find some higher order derivatives. If I start with this function here, the first derivative is going to be 7x cubed to the 6th minus 8x cubed plus 10x minus 3 plus 0. The second derivative of the function, which is the first derivative of the first derivative, is just going to be applying the rules to f prime. So that gives me 42x to the fifth minus 24x squared plus 10. And the fourth, there's a typo here. This should be the third derivative. This is going to be 210x to the fourth minus 48x. And then finally, the fourth derivative is going to be 840x cubed minus 48. Okay, now to apply that to something, this is a straight polynomial. Now to apply this to something other than a polynomial. Again, I'm going to rewrite this x to the 1/2 plus x to the minus 2. So the first derivative is going to be 1/2 x to the minus 1/2 minus 2x to the minus 3. Again, if you want, you can rewrite that as 1 over 2 square root x minus 2 over x cubed. Now, that's not necessarily the form you're going to want to use to find the second derivative, though. We'll stick with this. So we'll get a negative 1/4, negative 1/2 times 1/2, x to the negative 3/2, negative 1/2 minus 1 is negative 3/2, plus 6x to the negative 4th. Okay? So remember that the derivative means the slope. It's the slope of a tangent line at a point, the slope of a tangent line to a curve at a point. So if we're given this curve, this is a fourth degree polynomial, we want to find the slope of the tangent line at x equals 2, the instantaneous rate of change of this fourth degree polynomial at x equals 2. So first I'm going to find y prime, which is going to be 4 times 1/4 is 1. So x cubed minus 1. And then I'm going to evaluate that at 2 to get 8 minus 1, or 7. And 7 is the slope at that point. Now I want to write the equation of the tangent line to this curve at this point. I already know that the slope is equal to 7. And now I just need a point. Well, the x-coordinate of the point is 2. I need to find the y-coordinate by evaluating the function at 2. That's going to be 1/4 times 2 to the 4th minus 2 plus 2. These just cancel out. I have 1/4 times 2 to the 4th. That's 16. 16 divided by 4 is 4. So my point is 2, 4. So now I can write the equation of the line in point-slope form. That's going to be y minus 4 equals 7 times x minus 2. And then I can simplify this down to slope-intercept form by combining like terms and distributing the 7. That's going to be y equals 7x. I have a minus 14 plus 4, so 7x minus 10. And now to find the instantaneous rate of change of this function at t equals 3 seconds, I first take the derivative s prime of t as equal to negative 9.8 times t plus 40. And then I evaluate this derivative at t equals 3, negative 9.8 times 3 plus 40, which gives me a positive 10.6. The instantaneous rate of this change, the instantaneous rate of change of this function at t equals 3 is positive 10.6. We can also use tables to find derivatives. If we're not given the function explicitly, but we're given a table of values, we can evaluate these derivatives at these specific points. So we have this function here. We want to evaluate the derivative of this function at x equals 1. Let's first find the derivative. That's going to be 2 plus 4 times f prime of x. And again, I want to evaluate this all at x equals 1. So that will be 2 plus 4 times f prime of 1. Looking at the table, I see that f prime of 1 is 2. So I'll have 2 plus 4 times 2. Erase that. 2 plus 4 times 2, which is 10. Okay, over here, I essentially do the same thing. I have 3 times f prime evaluated at 2 minus g prime evaluated at 2. F prime at 2 and g prime at 2 are right there. So I have 3 times 4 minus 3. That's 12 minus 3, which is 9. Okay. Next problem, again, I'll have to refer to the table. The derivative of 1 with respect to x is 0. And then I have the minus sign. F prime of x when x is 5. So negative f prime of 5. F prime of 5 is 3. So the result here is equal to negative 3. Okay, here I'm going to take the derivative of x squared, which is 2x. Then I'll have 2 times f prime of x when x is 3, minus 5 times g prime of x when x is 3. I also need to substitute the 3 in here, so I'll have 2 times 3 plus 2 times f prime of 3, looking at the table, is 1, minus 5 times g prime of 3, which is 4. This gives me 6 plus 2 minus 20, or 8 minus 20, which is negative 12. Okay, and that's it.